Hello and welcome. In this lecture, we are going to be using the loading and saving API in concert so that we can actually load some state back from our painting save game. Look at this bit of code here. We are using a load function, and then we are going ahead and getting some state out of it that was set originally over here in this save function. As you can see, they are not the same object. They are just being loaded from the file, so that communication is happening via the file system. Let's dive in and see how that can be achieved. Okay, so last lecture we were able to create these save files, but we weren't actually able to restore the save files. Obviously that's very important to do, and that's what we're going to be doing in this lecture. But first of all, let's set up some saving from user input. What I want to be able to do is test that our saving is actually working by being able to save, draw a bit, and then restore, and actually have our painting restore to a previous point. So that is going to require us to have some user input to allow us to tell it when to save and when to restore. Now I'm going to do this with the A and B buttons from the controller. So the way I'm going to set this up is going to go into project settings, and I'm going to go to the input, and I'm going to add up some action mappings. One action is going to be the save action. It's going to be mapped to the motion controller right face button 1, which is the A button on the Oculus Rift. And then we're going to have the save, and we're going to have the load. And that's going to be mapped to the motion controller right face button 2. Okie doke, so I can save that. And then we can set up the mappings in the pawn itself. So we're going to have something to map to. So I'm going to create some private methods. They're going to be void save and void load. And I can go ahead and implement those just in the bare bones in the C++. So putting the class prefix in front of them and putting brackets as well. Okay, so now those are have got definitions, and we can set up finally the binding. So the binding is going to be a player input component, bind action, text is going to be save, and the E input event is going to be the IE released. So releasing is going to save, and then we're calling on this with a reference to the AVR pawn. In fact, let's just copy it. AVR pawn save here, like so. So that's that set up, and we can just copy and paste for load, replacing save with load in 2 places, and that should do the trick. So that's going to bind the A and B to these save and loads in here. And that means we can move our code here for creating our save game and actually saving it over to our save here. Okie doke. So that's what we've got. That looks great. And now we need to think about loading. So what we're going to be doing with loading. So we're going to need an API for loading. Let's go over to the painter SaveGame.h and create a public API for loading, which is going to be static because if you think about it, we want to get a uPainter SaveGame out of it, which means we don't actually have one. So it's going to be a static uPainter save game, and it is going to load, and it's just going to load from the default slot for now, but later on we'll have to add in some parameter to tell it where to load from. So we'll have to change that a little bit. Okay, so we've got load. We can go ahead and just create a bare bones implementation of that, which returns null pointer. And that's it. So I'm going to go over to vrpawn.cpp. And this is where it's going to actually do the loading. So we're going to call the uPainter SaveGame : load. And that is going to return us a painting, but hopefully one that was already saved. And then from there, we can get it to actually print out maybe some state that we saved in this save over here. Okie doke. So that's what we're going to be doing. Now let's have a little look at what the API for that loading actually looks like. The API in question linked against this lecture is the uGameplay static load game from slot API, and it looks very much like the save. except that it returns a U SaveGame, which could be a null pointer as well. So it could fail also, just like the saving could fail. But we give it a slot name and we give it just a user index. We don't have to pass in the SaveGame. It kind of makes sense. That's what you would expect. So that's how you are going to use it. And I'm going to leave it as an exercise to you to fill in and test out. So let's have a challenge definition. You're going to load some state. That's the idea. So we're going to populate a U property because the U properties on the U SaveGame subclass are what is going to be serialized and deserialized into that file. So you're going to populate that U property. Then you're going to set up loading to work correctly so that it works with that API we're using. And check it restores the data correctly. So if you go in the game, you hit the load button, maybe log something out to the console so that you can see that the U property value on the save game is coming back as it should do. And you should even check that it works between reloads of the game. If you quit the game, load it again, and hit the B button or whatever you've hooked up your input to, that it loads up the same state again. That's important because the save game should allow you to do that. Pause the video and have a go. Okay, welcome back. So let's give this a shot. So first of all, adding in the U property, let's go over to our SaveGame.h and add in some state. So I'm going to make it private. It's going to be : state. / state rather, and then we're going to have property, so it's going to be a U property so that it serializes, it doesn't have to be visible or anything, U property, and then I'm just make a string here, call it state, just for fun, and then we're going to create a public getter and setter, so we're going to have a void set state, which is going to take an F string, and is just going to do a state equals to new state, which is what I'm going to call it. I forgot to call it anything, the input, like so. So we're going to set the state, and then we're going to do a void get state, sorry, not void, it's going to return an F string, get state, no arguments, const, and it is going to just return the state, like so. Okay, so we've got our getter and setter for the state. Let's go ahead and use it. So in the VR pawn CPP where we're doing loading, then what I want to do on the next line is do a UE log where we basically just log out the painting, let's see, painting state is going to be %s, and that's going to be painting arrow get state, and then we need to do asterisk in front of that to make it the C string so that it can log out properly. Okay, and in this painting that we created, we actually have to set some state. So when we're doing save, this painting is going to be painting arrow set state, and then whatever we want to pass it. I don't know, hello world. How original. I'm going to add that in as the state when we save, so that when we load, we should have that state coming in as well. So there seems to be an issue with our load definition. Not sure quite why that would be the case. I'm just going to go ahead and build and see if that goes away. But we do need to go over to our Paint A SaveGame CPP and implement our loading there using our uGamePlayStatics API. So we've got this uGamePlayStatics load game from slot, which is what we're going to want. Okie doke, so it's going to be load from slot. The slot name at the moment is test. We are going to change that, so I'm not worried about the fact that I'm copying a text reference. Usually I would be worried. In this case, I'm not. So we are going to be loading from the slot, and we're going to have to cast it as well. So I'm just going to go and do that all in one line, casting to the uPaint A SaveGame, because it's not too long for a line, I think. You might disagree with me. You might choose to put it on separate lines, but I just wouldn't know what to call it when casting is the only thing you're doing. Okay, so let's go ahead and build that. I think there was an issue, so maybe if I go and have a look at the output log, let's see where my first issue is. Yeah, load has a problem indeed. Redeclaration of member. Do we have a load already? Seems odd that we would be redeclaring this. Let's go up. Oh, right, it's the semicolon. Always forget some little syntax thing like that. Always makes a bit of an issue. Okay, so let's test it out. So go over to Unreal, clear my logs, go ahead and hit play. and have a look at my logs. Okay, so first I'm going to hit the A button to save something into the file. And in fact, what we could do, just to make sure this is a completely clean test, is go ahead and remove the test.sav. Now, this actually will make it crash, so we should probably check that our painting is not null. So let's do if painting, then we're going to print out that we've got a painting state, otherwise we'll say that it hasn't saved. So let's do an else, and then do a UE log not found, something like that. Okay, and build that. Okay, let's give it a go. So I'm going to go ahead, hit play, and if I just try to load directly, so here's my output log, let's maximize that, and go over to my game, and just hit B to load, then it is saying not found, but not crashing. If I save first, there's no log message for saving, but then hit B, we've got painting save state, hello world. Great, so it has reloaded that state from the file. You can see that it's created the file as well. And what I want to show you is that if we go and reload the game, remember how initially it told us there was nothing found. If we go and reload the game and hit B, there you go, it's telling us straight away, painting state, hello world, which is different to the first time we launched it, which means that it has persisted that state between the two levels. So fantastic stuff. Hopefully you found the same thing and managed to get there in the challenge. Don't worry if you didn't. In the next one, we are going to be looking at how we can actually be serializing the state that is in our world so that we can reload the stroking state that we have of what we've painted. See you there.